An improper integral is one that has infinity involved in it at some point, kind of like the ones that I'm showing you here. And here's how we're going to deal with infinity. We're just going to replace it with a variable. And for example, if we were looking to evaluate something like this, I would just rewrite. I'd say, okay, well, let's find the limit as b approaches infinity of this integral between a and b of f of x dx. So let's do some examples because they get a little bit interesting. I'm going to take this integral, so I'm going to be going from 1 to infinity of, let's say, 1 over x squared dx. And you know exactly what 1 over x squared looks like in this region. It's just a decreasing function, so we're just finding this region, until we get to infinity. So we'll have the limit as b approaches infinity. We're going between 1 and b, and we just have x to the negative 2 dx, and that's fairly easy. We can take the antiderivative of that. We know it's going to be negative 1. Oops. Well, forget about that. Negative 1, x to the negative 1 between 1 and b. So we're going to eventually take the limit as b approaches infinity of, well, this is going to give us negative 1 over b minus negative 1 over 1. So that's going to give us plus 1. And as b approaches infinity, this whole thing is going to be very close to 0. So the area ends up just giving us 1, which is a little bit interesting, because let's look at something else, another function that's very similar. If I was going to find the area under 1 over x, so let's do the same thing. The limit as b approaches infinity. We're going between 1 and b of 1 over x dx. Well, that behaves a little bit differently because of, it's a good question, why? Because we know this is going to give us the antiderivative of 1 over x is ln x as we go between 1 and b. And when we plug this in, eventually we're going to be looking for the limit as b approaches infinity of ln b minus ln 1. ln 1, is just 0. But ln b, that doesn't become anything. That just keeps getting bigger and bigger and bigger. So this ends up being infinitely large. The area under 1 over x ends up being infinitely large, whereas the area under 1 over x squared was just 1. Kind of strange. Very strange. And you are right to beg the question, what is so different? But yet there is. That x to the first makes a huge difference. Here's what we say. What we say is that the second function that we talked about, this one, we say that this diverges, whereas the first one converges to 1. And I'm going to stop this, but that's an introduction to improper integrals.